Hi guys, this is Ms. Miner, and this is lesson 8E, and we're going to talk about scientific notation today. Scientific notation is shorthand notation. So when you're texting and you write like LOL or, IY, ILYSM, right? I love you so much. And you just do these little shorthand because you don't want to type things out all the time. And scientific notation is a shorthand notation for math, for big numbers, really, really big numbers, and really, really little numbers. We're going to skip over the negative exponents review for right now. And we're just going to kind of look over here at these really, really big numbers and these really, really little numbers. And when in math, when we're doing these calculations with really big numbers and really small numbers, it can be kind of tedious to have to write out a really big number over and over and over again, or a really small number over and over again. What we end up with is writing all of these zeros, right? So I'm writing 0, 0, 0 over and over and over again, or I'm adding all these zeros on the end to make it a really big number. And so it gets kind of tedious to do that. And so what we've come up with is a shorthand notation to simplify writing these numbers out. Especially these numbers we could probably handle, but some numbers are really huge. If we're calculating, let's say, light years, number of light years from our galaxy to another galaxy in space, those numbers tend to be really, really huge. And so we want to shorthand those so we don't have to end up writing them out over and over again. And what we have used in order to shorthand is the rules of exponents. We are going to use the rules of exponents, and we use the rules of exponents and basically place values in order to be able to shorthand numbers. And we call it scientific notation because we use it in science a lot. But also because we use it in math. But a lot of times you'll see scientific notation when you're working in science, when you're calculating. In fact, I used scientific notation a whole lot in my chemistry class, if you'll believe that. So scientific notation uses negative numbers negative exponents. So if a number is written in scientific notation, we use a negative exponent. And that means that the number itself is a number less than 1. And it kind of looks like this. And the reason why we put times 10 on the back is because we're actually talking about place values. And if you'll remember back in elementary school, when you talked about place values before, let's put some place values here. Here's our decimal place right here. And so this would be the ones, and this would be the tens, and this would be the hundreds, and then this would be the thousands. I'm going to abbreviate this, right? And then back here behind the decimal place would be the tenths. And this would be the hundredths. And this would be the thousandths. Okay. So what you'll notice about this place value is when I increase in place value, I'm increasing by a power of 10, right? And so that's exactly what's happening here with our scientific notation. I'm either getting bigger, right? I'm adding a power of 10. I'm adding a power of 10, or I'm smaller than the ones, right? This would be, the ones would just be, right? This would be the ones down here, and then increasing from 1 to the tens, right? And then back here, I am going down in power. Sorry, this would be 2. This would be 10 to the negative 3 here. This would be 10 to the negative 1, right? Okay. So now you can kind of see where this piece of our scientific notation comes from. The 0.45 at the beginning, it comes from the original place value here. So what we try and do in scientific notation is we only want to have a ones place. Let me highlight this with a highlighter. We only want to have a ones place value. That keeps us from getting a really, really big number, right? Or a really small number, putting a lot of extra place values in there. And sometimes we have up to like a hundredths place. Usually we round off after the hundredths place. So these are really the only place values that we have. And these place values back here are kind of nice place values to have. And so when I'm writing scientific notation, it keeps me with just one place value and sometimes a couple of decimal places, right? Sometimes I'm going to have a couple of decimal places back here, but I absolutely am going to have a ones place, and then sometimes I'm going to have a tenths place or a hundredths place. So you can see this one has a ones place, and then it has a tenths place. And then this part represents all of the other place values that I've removed when I move the decimal place. Okay, so we'll kind of see how this works in just a minute, but that's where those numbers come from. They're coming from place values. And so a really, really big number would have a positive exponent, and a really, really small number is going to have a negative exponent. And what that means is the number is either going to be less than 1. And remember, if I have a number that has a negative exponent on it, what that really means is I have a fraction, right? It's 1 over that number. And so it is a number that is smaller than 1. And that's kind of what we're talking about here. When I have a positive exponent, it's a number greater than 1 by that many place values. Okay, so let's see how this works. Here's kind of the setup that we use for scientific notation. I definitely am going to have a ones place, okay? And then I'm going to have up to 2 place values. Now, I could have more depending on how accurate I want to be. But in Ms. Miner's class and Mrs. Zeider's class, what we'll probably do is just round off to the hundredths place for most of our stuff. That's a general rule that you can follow. Just round off to the hundredths place value. But you absolutely have to have a ones place. That is absolute. Okay. And then I absolutely have to have times 10 to an exponent power. So those are the parts that I have to have. And this is kind of our setup for writing scientific notation. Now, when I'm writing scientific notation, let's use some of these. I'm going to make this just a little bit bigger here. Okay, so here is our setup. And then what we want to do is we want to write this number in scientific notation. So we're going to write this number in scientific notation. And what I have is a really, really small number. So you should already be thinking in your minds, what kind of exponent am I going to put in this box up here? Sorry, let me switch over to my pen here. What am I going to put in this box right here? Is it going to be a positive exponent or is it going to be a negative exponent? And hopefully you're already thinking in your mind that it should be a negative exponent. I can even already put it in the box as being negative. Then I need to have a number in my ones place. So I need to have a number in this ones place. So in order to put a number in scientific notation, what I do is I look until I get to the very first non-zero number. So find the non-zero number, and that's going to be the number that goes in my ones place. Then any numbers behind it, are going to be my decimal places here. Okay, now the only thing I need now is to fill in my exponent number. And so my exponent number is how many place values did I have to take off in order to get this number to be 6.76. So I'm going to count. I had to take off 1, 2, 3, 4, and then I had to move the decimal place one more place value. So I'm really not taking off those place values. I'm kind of moving the decimal place, right? And I had to move it 1, 2, 3, 4, 5 place values because my new decimal place is in between the 6 and the 7, right? That's where my new decimal was. So in order to figure out what my exponent should be, I'm kind of thinking about how many place values did I have to move the decimal to get it in between the 6 and the 7 there. And I had to move it 1, 2, 3, 4, 5 place values. So that's going to be my exponent. And it's negative because this is a very small number. It's less than 1. So my scientific notation for this number will be 6.76 times 10 to the negative 5. And that's where my shorthand notation, that's what my shorthand notation looks like. That is the scientific notation for this very small number, 6.76 times 10 to the negative 5. Now, I could round this off if I didn't really care, but the more decimal places I put back there, the more accurate my scientific notation is. And so, like I said before, a general rule for Mrs. Miner and Mrs. Zeider is give at least 2 decimal places back here and then round everything else off. Like if, let's say I had a 3 back here, then I would do 6.76 and then I would round off the 3. I hope that makes sense. Okay, let's try another one. The parts that I absolutely have to have in order to have scientific notation is I have to have this ones place. All of these decimal places back here, even, Ms. Miner says round to the hundredths, but those decimal places back there, I actually don't need them. And sometimes we do round only, so we only have a ones place. But, like I said, these decimal places back here help my scientific notation be more accurate. And so we're going to practice just rounding everything off to the hundredths place. And we'll be a tiny bit more accurate that way. Okay, so let's start over again. This time, we're going to do a big number. I'm going to kind of leave that so that we can see it. And here's my big number down here. I'm going to change some colors up here. Here's my big number. We're going to do this big number, and we're going to write it in scientific notation. And so I need to have a ones place. And again, I just look from the left. And the very first number that I get to that's not a 0, that's what's going to go in my ones place. Then I'm going to say, okay, well, I'm going to put the decimal place there now, right? Because right here is my decimal place, right? And now my decimal is right after the 6. And so in order to figure out what exponent should be on my 10, and remember, we use the number 10 over here because that's my place value, right? Each place value that I go is increasing or decreasing by a amount of 10. And so that's why we use the times 10. And so I just want to think about how many decimal places am I kind of getting rid of, or am I moving the decimal? Well, on a whole number, on a really big number, the decimal place starts at the back and then it moves up. So I'm moving up 1, 2, 3, 4, 5 decimal places. And this one's going to be positive exponent because I have a number that's greater than 1. I'm moving my place value, greater than 1 this time in order to have scientific notation. And so in this case, right, even if I put these zeros here, that doesn't mean anything. There was only zeros there to begin with. And so my scientific notation this time is 6 times 10 to the 5th power. And there's my scientific notation. So sometimes we want scientific notation, and sometimes we have to take scientific notation, we have to convert it into standard notation. So how would we do that? Well, this is the way that I like to do it. This is a positive exponent, so this is a number that's going to be bigger than 1. So I want my decimal place to make this be a big number, right? So if I write the number 9, and then I know I have to move my decimal place 5 place values. If I want a big number, am I going to move my decimal place this direction or that direction? Hopefully you said you wanted to move to the right to make this a big number, because we do. And so I want to move my decimal place 5 place values to the right. And so I'm going to go 1, 2, 3, 4, 5, right? And I'm kind of moving my imaginary decimal that's here, and I'm moving it 5 places to the right, and then I just fill in with zeros. And that's my really, really big number. This number happens to be 900,000. 900,000 is the same as 9 times 10 to the 5th power. So if I want to convert this number down here from scientific notation to standard notation, I do the exact same thing, but looking at this is a number that's very, very small. It's less than 1. So I start with my number, and because I know I'm thinking about this, do I want to move my decimal place this direction to make a small number, or do I want to move my decimal place this direction to make a small number? Hopefully you're thinking in your mind, I've got to move my decimal place this direction to make this a really small number. And so that's what I want to do. I'm going to kind of start with my 7.3 over here, because I'm going to add some decimal places in this direction. So 1, 2, 3, 4, 5. I'm making this a very small number, and then any kind of jump that I made or place value that I made that didn't have a number in it, I just fill in with zeros. And so if I want to clean this up and make it look pretty, right, I can put 0, 0, 0, 0, 7, 3. And there is my very, very small number. Now, if you'll notice, I only have 4 zeros in here, but I went 5 places because one of my place values was going from the 7, right, until in front of the 7. Because my decimal place was moving to the left, the 7 actually filled in one of my decimal places, but we still count that. That was 1, 2, 3, 4, 5 decimal places. So you're going to have to be careful about that and don't get tricked, because when I moved it to the right, 1, 2, 3, 4, 5, I had 5 zeros, right? So I'm not just adding zeros to my number. I'm not just adding 5 zeros to my number here. I am counting how many decimal places do I need to move from where the decimal originally is. So that's kind of, you're going to have to be careful about that. That's why I make these little loopy things down here, these little like jumpy things. It helps me count, and then I can just fill in any zeros that I need. So I kind of do it that way. Or if you don't like that, method, you could just make boxes. So let me show you another method that you could start with 7.3, and then instead of making jumps, you could just make boxes. This is going to be 1, 2, 3, 4, 5, and then put your decimal place, and then fill in each of the boxes. If you like that method better, that's another way to kind of think about it, because then you have the actual, like, this looks like a place value. So that might help. And you're going to have to practice and come up with whatever method you like best. Okay, so let's move ahead. Let's just try a couple. I have kind of a setup over here, and you can make your setup. To start with, give yourself a ones place value, and then you can give yourself maybe a couple of place values behind the decimal, and then say times 10, and then give yourself an exponent box, right? Whatever you like, you don't have to set it up this way, but it's a good practice in the beginning. in order to be able to remember all the parts that you need to fill in. Okay, so let's practice with a really big number. If you're already thinking about this, then you can think about that you need to have this be a positive exponent because it's a number that's greater than 1. And then the first non-zero number that I get to is 6. That's going to be the number that's here. And then I can look at these next two, and I want to round off to 2 decimal places. This 2 right here is telling me that this 7 is going to remain a 7. If it were a 5 or higher, we could round it up to an 8 instead. But then we just kind of remove these other place values. But what we are really doing is saying, well, how many place values do I need to remove in order to get the decimal to between the 6 and the 3, right? My new decimal place is way up here between the 6 and the 3. And so how many place values did I need to move the decimal? 1, 2, 3, 4, 5, 6. So I moved the decimal place 6 place values in order to get the decimal to where I needed it to be for scientific notation. Okay, now let's do it again. I need a 1's place value, and then maybe a couple of place values back here, and an exponent. This should be a negative exponent because this is a number smaller than 1. And the first non-zero number that I get to in my number is a 5. There are no numbers back here, so I don't need to fill those in. But I do need to figure out how many place values do I need to move the decimal in order to get it right after the 5 to right here. And I need to move it 1, 2 place values. That's going to be my exponent. So to make this nice and pretty, let me just slide this down. To make this nice and pretty, our scientific notation would be 5 times 10 to the negative 2 power. And that would be our final answer. And I didn't need these place values back here because there were no other numbers behind the 5. All right, one more number. Well, let's do the last couple. Let's just do a couple more just to kind of make sure we've got it. Okay, so here's another small number. Let's do this one really quickly. I'm going to need a 1's place value. The first non-zero number that I get to is a 1. That's going to go in my 1's place. And then I'm going to have a 7 behind it. I can put that in. And that's going to be times 10 to an exponent power up here. And this is going to be a negative exponent because this is a number smaller than 1. And now my new decimal place is way up here. And so I want to move my decimal place 1, 2, 3, 4, 5 places. There's my scientific notation. Okay, last one. Let's do one more where we have a number that is bigger than 1. And I just want to set this up. So I'm going to give myself a couple of place values times 10. And then I need an exponent up here. Okay, my first non-zero number that I get to is a 1. That's going to go in here. And then I can put the other numbers behind it. I've moved my decimal place to right after the 1. So this is getting moved 1 place value. So my scientific notation for this number would be 1.05 times 10 to the first power. All right. So hopefully that makes a little bit of sense. What we're doing, we're just kind of moving place values and kind of shorthand notation for really big numbers and really small numbers. Now this wasn't a really big number, but we're just showing that we can make scientific notation out of any number. Okay, so now let's practice taking scientific notation and turning it into standard notation. So here we have a number that's in scientific notation. Oh, sorry. It's not in scientific notation. What if I have a number that looks like this, right? Well, the rule for, I apologize, I screwed up what I was wanting to say about this slide. And what I want to say about this slide is if you look at this number right here, Remember, the rule for scientific notation is that I can only have a ones place. I cannot have a hundredths place up here. So this number is not in correct scientific notation. I need to put it in correct scientific notation. If I have a number that's like this and I need to put it in correct scientific notation, I can only have a ones place and some other numbers behind the decimal. And this one, we need to put it in correct scientific notation. Now look at this number. This is a number that's greater than, this is a number that is greater than 1. I should have a positive exponent here. But I need to only have a ones place here. So I'm going to take this decimal place and I'm going to move it one more place forward. This was already an exponent of 3. And I moved the decimal place one more place. I need to give this one more positive exponent in order to make this correct scientific notation. So my new number that is incorrect, that is in the correct form for scientific notation, is going to be 8.84 times 10 to the fourth. And that's going to be important to us when we start multiplying and dividing with scientific notation in a second. Because if we end up with a number when we multiply or divide our scientific notation and it is not in correct scientific notation form, then we have to know how to change it, to put it into correct scientific notation form. So if I need to change this, right, this number, 88, is bigger than 1. So I'm adding another exponent in order to get it there. What if I had a number that was smaller than 0? So I'm just I don't have one here, but let me just kind of give you an example. Let's say I had a number like this. Let's just use this. Let's say my answer came out to 0.884 times 10, and let's just say to the third, right? Well, if I wanted to put this number in correct scientific notation, this number up here is smaller than 1. And so when I move this decimal, I'm going to still make it 8.84, but this time I would have to take away one of my exponents because I started out with this number that was smaller than 1. And so when I change my scientific notation, I have to subtract an exponent because this number gets a negative exponent. Now, it's not necessarily going to end up a negative number or a number smaller than 1 in the end, but because my place values, right? My place value of my result was smaller than 1. So then I needed to move the decimal place. So let's do some multiplying and dividing, and you'll kind of see what I'm talking about in a minute. Okay, so when I'm multiplying or dividing, what's awesome about scientific notation is that it still follows all of the same exponent rules that we had before. And the truth about scientific notation is when I have really, really big numbers and really, really small numbers, scientific notation, it actually makes it super simple to calculate those kinds of numbers because we can use our exponent rules. So here's kind of the steps that we want to use. Whenever I have scientific notation, what I do is, the first thing that I want to do is split it into just the numbers, the constants, and the powers of 10. So I'm going to kind of take my problem, if you'll notice my problem over here, and here was my plain number in front, and here was my plain number in front. I'm going to take those and multiply them together. And then I'm going to take my numbers with the exponents on them, and I'm going to use exponent rules to combine those. So, and then you can see that the result of that, when I got it, this number was bigger than 1. And so in order to readjust my scientific notation and make it correct scientific notation, I had to move the decimal place one place value. And because it was a number bigger than 1, we're going to add one exponent here and my final answer. Okay, so we can kind of see how this is going to work. We're going to split up our expressions into constants and powers of 10, and then we're going to multiply the constants together. We can use our calculator for that. And then we're going to multiply the powers of 10 using the product rule, or in a minute, we're going to use the division rules for exponents. Either the product rule or the quotient rule we're going to use for the exponents part. Then we're going to write our answer in scientific notation and make any adjustments that we might need. Okay, so here is, I'm going to grab me a calculator here really quick, just so that I can multiply my decimals together. Okay, the very first thing that I want to do, this is a multiplying problem with scientific notation. And so I just want to take my constants from the beginning of the problem, and I'm going to multiply those together. 9.8 times 5.04. Now, I don't want to get confused with which is decimals and which is the multiply sign. So I'm going to put these in parentheses, and we'll just multiply them together like this, 5.04. Very first thing is I just rip my constants off of the scientific notation, and I multiply them together. And I'm going to put these in my calculator, because I'm not very good at multiplying decimals in my head. I don't know about you. Maybe you're really good at it. But I'm going to take 9.8 and times that by 5.04. And I'm going to end up with 49.392. That's what it said in my calculator, 49.392. That's what I got when I multiplied the constants together. And then I'm going to take the 10 and the exponent, and I'm going to multiply those together. 10 to the 5th power times, and we can probably put a dot for our 10 to the 5th power times 10 to the negative 2 power. And remember my rules of exponents. My rules of exponents say if I have a like base, this is a 10 and this is a 10, then all I have to do are add up the exponents. And so when I add up the exponents, I get 10 to the 3rd power. So now my problem is 49.392 times 10 to the 3rd power. So I have to make an adjustment because this number right here came out with a tens place. I have a ones place and I have a tens place here. And I just want a ones place. So I'm going to have to make an adjustment and move that decimal place. And so this is a number that's bigger than 1. So I'm going to be adding 1 decimal place over here. 3.49, and then we can round up. This is greater than 5, and so we're going to round up to 4.94 times 10 to the 4th power. And that's our result. Okay, let's try one where we're dividing. Same kind of situation is going to happen. We're going to kind of rip this problem apart into 2 parts. And we're just going to take the constants in the front, and we're going to divide those in our calculator. So I'm going to take those, I'm going to divide it in my calculator. So 1.24 divided by 6.1 is going to give me 0.2032786. We don't need all those numbers, right? But we do need a few of those decimal places. So let's give ourselves just a few of those decimal places. We got 0.203, and then I'll give myself one more decimal place, 3. We're going to round up and make that 3. Okay, so that was the first part. Now I'm just going to look at my exponent part, my base tens, right? This is a 10 and this is a 10, so I can use my exponent rules in order to combine these. So my exponent rules say if I have a negative exponent, I need to move it to the opposite location. And so this is going to be 10 to the 6th times 10 to the 3rd, and I just add up my exponents. Rules of exponents say if I have a negative exponent in either the denominator or the numerator, I have to move it to the opposite location. So I moved this one to the top, and then I added the exponents up. Then I have to make an adjustment. Because this is a number that's smaller than 1, I'm going to have to move my decimal place over just a little bit. And So I'm moving it. This is a number that's smaller than 1, so I want to subtract 1 exponent power when I move that decimal place. And my final answer, let's just make this a little bit bigger. My final answer is going to be 2.03, and I can round this decimal place off now, times 10 to the 8th power. And there's my final answer, okay? And I just use my plain old rules of exponents in order to do that. Okay, let's do one more off of your homework. Let's do this problem right here. We want to write it in scientific notation. A good idea would be practice with your own. Pause the video, practice on your own, see if you can write it in scientific notation, and then check your work and see how you did. Okay, if you're checking your work, what we want to do is we kind of want to set this up. I want a 1's place value and maybe a couple of place values back here, times 10, and then an exponent box up here to fill in. I want to write in the first non-zero number that I got to, right? And then I'm going to move my decimal place all the way over to there. Hold on, let's back up just a little bit. I want to move my decimal place all the way over to there. And then there's a couple of zeros behind it, so we can fill those in if we would like. And then I want to count up how many decimal places did I have to move. The decimal, 1, 2, and so this is a number smaller than 1. This is going to be a negative 2, and there's my scientific notation. I'd like to do one more problem from our homework, or maybe a couple more problems from our homework, just to make sure that we're feeling okay about it. And I gotta grab a homework assignment in order to do that. Let's take a look at some of these problems from the back page. And let's do a couple of problems from the back page just so that we feel confident about what we're doing. Let's take a look at just number 4 from our homework assignment. Let's do one more division 1. And so number 4, straight off of our homework assignment, is 7.83 times 10 to the 3rd power and 0.37 times 10 to the 1st power. Okay, so I want to use my rules of division, and I just kind of like rip off this front part. That's kind of how I think about it. And I just divide those numbers. I put it in my calculator even. And so in my calculator, I'm going to put in 7.83 and divide by 0.37. And this is really great because we love working with decimals because we can just plug them into our calculator. 21.162. Just going to write that down there. And then I take the back part and I'm going to use my rules of exponents to do the back part. My rules of exponents say, where are there more exponents? There's more exponents in the numerator on this one. This one doesn't have a negative in the denominator, so I don't have to move any of my decimals, right? And so this is going to be times 10. This one's going to cancel out one of these from the top. So 3 minus 1 gives me a 2. And I just subtract my exponents just like I normally would. Okay, so now I take a look and I notice, hey, this has a tens place. I need to make an adjustment here in order for it to be in correct scientific notation. And so I'm going to move the decimal place 1 place. This is a number bigger than 1, so I have to add an exponent power back here. And I'm going to get 2.12, and I'm going to round this part. If you'll notice, this number is bigger than 5, and so it's going to round up. And 2.12 times 10 to the 3rd power. And there's my final answer. Let's do one more straight off of our homework assignment. Let's do another multiplying one just so that we feel confident about what we're doing. And we're going to take number 2 off of our homework assignment and do number 2. It says 9.8. This is number 2 right off of our homework assignment. 9.8 times 10 to the 5th. And 5.04 times 10 to the negative 2. Okay, we want to multiply them together. So I just take my constants, just the number part, and I multiply those together in my calculator. So this time in my calculator, I'm going to put in 9.8 and times it by 5.04. And I'm going to get 49.392. And then I'm going to take the back sides of my scientific notation and apply my product rule. My product rule says as long as I have like bases, this is a 10 and this is a 10, all I have to do is add up my exponents. So I'm going to get times 10 to the third because 5 minus 2 or 5 plus a negative 2 is 3. Now looking at this, again, I have a tens place up here, and I can only have a ones place in scientific notation for it to be correct. So I'm going to have to move my decimal place one place value, and because this is a number that's bigger than 1, I'm going to add one place value back here. And I'm going to kind of round off some of these other numbers back there. So my final answer is 4.94 times 10 to the fourth. Okay, make sure that if you have any questions or need some clarification anywhere about scientific notation, you can contact me or Mrs. Zeider, jump on one of our Google Meets. You can come get after-school tutoring from us on Tuesdays and Thursdays. But make sure if you have any questions or need some clarification anywhere that you're getting a hold of us so that we can help you out with that. Okay, good luck, guys.